Hello, my name is Pong. I am pleased to present our work titled A Mathematical and Sentiment-Based Framework for Tourism Trend Forecasting Using Social Media Text Mining in Thailand. This work is collaboration between Mahasak Titiporn and myself, Pong. Tourism is crucial role in Thailand's economy. However, tourist behaviors have shifted dramatically due to technology and social media influence. Platforms like Twitter provide a real-time sentiment that reflects traveler intentions and emotions. Unfortunately, many existing forecasting models overlook this dramatic sentiment layer. We saw an opportunity to bridge that gap by integrating sentiment analysis and formal mathematics to forecasting model. About the research objective, our goal was first to classify sentiment from tourists, related sentiment from Twitters, and now is we call X, right? And the other one forecast future tourism interest to use that sentiment data to forecast future tourism trend. And the third to ground the framework in mathematical rigor by validating a set of 8 theorems that model social sentiment behavior over time. This slide shows the overview of the framework of our approach. So we start by collecting the data, real-time data from Twitter or X about the tourism related hashtag and keywords that we are setting. And then we perform the sentiment analysis using SVM or support vector machine based classifier. And then we try to extract the meaningful features like hashtag frequency and also temporal pattern. Then the heart of our contribution lies in the validating mathematical theorem that describe behavior patterns in social data. And finally, we use linear regression model to forecast trends, um, such as like a Google search interest that we use. Here is the output of our framework. Then we can understand the trend of the Twitters, and we can understand more about the sentiment of the society that interested in the tourism in our based on our keywords, right? Okay, here is our overview of the framework. And for the sentiment analysis, we use an SVM kernel-based feature. Despite work with the noisy and unstructured tweets because of their natural language processing, right? It's natural language. We don't have any structure of them, and we try to understand the insight of the meaning and also extract the sentiment from the tweets. Okay, here the pre-processing have to be applied to clean data to more easier to analyze. And our classifier achieve high accuracy of 93.67%, and the model labels each tweet as the positive, neutral, and negative. There becomes a key feature for the forecasting phase. Now, as we can see, the accuracy is quite high. It's very important because if this accuracy is not higher enough, the next step of the prediction will be have some problem based on this accuracy, right? So it's quite good, the accuracy for the next step. And then here, the highlight with mathematical side of our work, we propose and empirically validate 8 theorems. And there are convergence of sentiment estimation, linear separability, linear separability of sentiment and forecast linearity, and also temporal feature stability, Zipf's law of attacks, and temporal auto correlation, and nonlinear mapping improves separability, and temporal risk approximate expected risk. Here there are all of the 8 theorems that we proposed. So their theorems property like sentiment coverage, autocorrection and overtime, and hashtag distribution behavior. Okay, so the all of them support us to analyze in details of the tweets, and they help to ensure that our model isn't just empirically strong but also theoretically ground. So they very uh, important for this work, and it's the main part of our proposal. If you want to see the details of each theorem, you can see in the paper. Okay, we just show the name of the theorem here. And then, okay, next is the predict future tourism interest. We use linear regression, it's very simple one. And our feature includes sentiment score from the previous step and tweet frequency and also the hashtag density. And the model performed with Pearson correlation with 0.912 is quite good one, and R square score is 0.832. When I compare with the actual search interest data, it's very correlate with the real data. And about the experiment setting. Here, actually, we use Twitter API or X API, right? To collect the data, and we contain the tourism-related keywords we use in Thai language. This one is like travel, accommodation, sea, Chiang Mai, Pattaya, for example, of the keywords we use to search for the data and collect them to the database. And the time frame of the data, we use the data from January to December 2023. And the number of tweets, we have 45,000 tweets. It's quite a lot. And then we do the pre-processing for the whole of the data. We tokenize them and remove the stop word and do a stemming and then extract the hashtag from the data. And then we use the label sentiment to annotate using hybrid lexicon rule-based model. Here we use positive and negative to label the data for the training data, and also we use this data to train the model SVM sentiment classifier. We use to train 80% and the test data the remaining 20%, and using Google Trends data as a reference of actual travel interest. So we use a lot of techniques to try to evaluate our framework. Okay, and here is the result of the experiment of our framework. Our key result show that the SVM, okay, the SVM model classifies sentiment with over 93% accuracy. But for the regression, okay, the accuracy is here 91.8, right? And the random forest with 100 trees here is 90, just 90. So the best one is SVM for sure, right? And what else? So here's the result of the sentiment classifier, and the best one is the SVM. So we use SVM to be the sentiment classifier for our framework. Okay, and then we discuss a little about the result. SVM model successfully handled noisy text, of course, because we the data was the high dimension of the the data, and SVM is quite good for the data with high dimension, of course, and very powerful, powerful one to understand and forecasting tourism trend. And use we also use the formal theorem, right? Offer deeper insight tourist behavior. And what else? We also use the mathematical theorem, add robustness, and explain why sentiment behave the predictable way our time. And the framework has both theoretical value and real-world applicability. And also the linear regression that we try to use with the sentiment features show the high predictability, of course, and we include them into the model also. And the social sentiment is robust predictor and real world tourism interest because we use tenfold validation also to evaluate the model. And for the practical implication, okay, uh, the tourism boards and marketing strategy can use this kind of the model to predict demand. Okay, and also we can understand about the demand in the future, and we can optimize the promotion, right? Campaign. What kind of the campaign we're going to propose for our customer, and resource allocation, how to support a lot of customer at the time when they like a high season, and crisis response and image repair. Well, okay. And bridge gap between real-time public mood and tourism planning. So this is a practical implications, and also here is the conclusion of our work. So this study successfully integrate machine learning, sentiment analysis, and formal mathematics to enhance tourism forecasting. And the sentiment aware model outperform traditional models both accuracy and interpretability. Our hope is that this work inspire further integration of social media to the real-time decision making. Okay, that's all. Thank you very much for listening. Bye bye.